Topics in post-harvest technology. Precooling methods, vacuum and hydrovac cooling, Part 2. Vacuum cooler mechanics. To vacuum cool requires first a strong steel container with hermetic seals, a vacuum pump, and an ancillary or auxiliary refrigeration system. The container must be strong enough to withstand the force of air, which is approximately 14.7 pounds per square inch at sea level, pressing on the outside of the container during operation. If not strong enough during operation, the vacuum tube or container could implode, that is, literally collapse like a stepped-on aluminum can. Hermetic seals allow for the efficient development of the required vacuum. Hermetic means airtight. To increase cooling efficiency and reduce the size of the vacuum pump, a refrigeration system is often incorporated into the sealing of the vacuum tube. Here is a side view schematic of a vacuum tube. To the right, we have the vacuum pump, which is on the outside of the tube. The dark black thick line represents the vacuum tube wall, and within you can see pallets of product. In the ceiling of this tube, we have refrigeration coils, and you'll notice there's a drip pan to collect condensed water. The refrigeration system is not cooling the product, however. Remember, within the tube during operation, there is essentially no air. So no air is available to flow around the product to cool it. It's a vacuum. The refrigeration system is used to freeze or condense the water vapor that fills the vacuum tube during its operation. This freezing or condensing sets up a humidity gradient, which allows water vapor to more easily leave the cooling product. Remember, the water inside the tissues is rapidly boiling and leaving the tissues. At the surface of the tissues, the relative humidity is essentially 100%. By freezing the water vapor or condensing it using refrigeration coils, at the surface of those coils, the relative humidity is going to be near zero. So we've set up a gradient or potential, and this is going to allow water vapor to more easily move away from the product. Using refrigeration coils in the vacuum tube reduces the size, that is, the horsepower requirements of the vacuum pump used with the system. Again, since we are potentiating the system by freezing or condensing the water vapor that fills the tube during cooling, the system is more efficient, so we can make it work with a smaller vacuum pump. Let's now discuss a hydrovac cooler. The wilting of iceberg lettuce is usually not a problem during vacuum cooling. However, for commodities such as celery, leaf lettuce, and romaine lettuce, visible wilting can occur during vacuum cooling. To prevent this wilting, the Hydrovac system was developed, which incorporates water shower pipes within the vacuum tube ceiling. After the tube is loaded and the doors are closed, at the beginning of the vacuum cycle, the water pipes are turned on for approximately 60 to 90 seconds to thoroughly wet the produce. When the pressure in the tube is reduced to the boiling point of the water, it begins to boil. Remember, this is the flash point, the point at which the boiling point of water has reached the temperature of our product or the surface water, and therefore the water flashes or immediately begins to boil. As the water boils from the surface of the produce, it removes heat from the underlying tissues. As with regular vacuum cooling, the air pressure is rapidly reduced to 4.6 millimeters of mercury, so the water will boil at 32 degrees Fahrenheit. Halfway through the cooling cycle, the water is turned on again for approximately 20 to 60 seconds. This ensures that there is enough water on the surface of the produce. So rather than all the water for cooling coming from the commodity's tissues, the supplemental surface water allows the product to be cooled while simultaneously conserving the water within the commodity's tissues. Some cooler operators will also drench the product with water at the end of the cooling cycle to ensure that it is at maximum firmness. Hydrovac cooling therefore allows many more commodities to be cooled since wilting is essentially eliminated. Hydrovac cooling is regularly used to cool wilting-susceptible commodities such as leaf lettuce, romaine lettuce, celery, and sweet corn. For sweet corn, the husks, which are often left on the ears, can rapidly lose water and turn gray-green. This would occur during the regular vacuum cooling process, but with a Hydrovac, husk drying is prevented. This is a video about vacuum and Hydrovac cooling.
This hydrovacuum tube, or Hydrovac for short, is being staged to accept a large, mixed load of vegetables. A Hydrovac utilizes water during the vacuum cooling process, which minimizes water loss from the vegetables. It is therefore adaptable to a wide range of vegetables, even crops prone to wilting such as celery and lettuce.
So what happens to the water? Is it just going to be circulated? Yeah, that's pretty much drains out. You know what? This one does. This one does recycle. Some of them are one-time use. Like that tube over there is one-time use. We add chlorine to it. We put a 50 parts per million.
Once the vegetables have been placed, they are automatically moved into the Hydrovac chamber. The Hydrovac chamber is often referred to as a tube, and this tube is very large, able to accommodate over 20 pallets of product during one cooling cycle. When the cooling cycle begins, the produce is flooded with water for 60 to 90 seconds while the air in the tube is removed using a large pump. The air pressure will be lowered to approximately 4.6 millimeters of mercury, at which point water boils at 32 degrees Fahrenheit. A second 30 to 60 second shot of water is applied to the produce halfway through the cooling cycle to ensure that the produce will not wilt during cooling. After the produce is cooled, the vacuum is released, a door is raised, and the product exits the tube. This product is receiving a final spray with water to ensure that it remains firm and can reach its destination market in ideal shape. The tube operator checks the product temperature with a handheld probe. If not sufficiently cooled, the product will be returned to the tube for another cycle of cooling. The Hydrovac can be run without a water wash for commodities that cannot be wet, and this process is called vacuum cooling.
So what are the advantages and disadvantages of Hydrovac cooling? Well, it is a relatively gentle method, and it is a fairly quick method. It can be used with many more commodities than are used with straight vacuum cooling, as wilting is essentially eliminated. The Hydrovac cooler can also be run as a straight vacuum cooler for use with products that cannot be wet. However, waterproof crates or cartons must be used with a Hydrovac cooler, and waterproof cartons are more expensive than unwaxed cartons. Wax cartons are also more difficult to recycle. It is expensive to buy or rent and operate a Hydrovac tube, and of course, as with any vacuum system, worker safety is a concern. Summary points. Pre-cooling is the rapid removal of product heat before storage or transport. To vacuum cool requires a strong steel container with hermetic seals, a vacuum pump, and an ancillary or auxiliary refrigeration system. The ancillary refrigeration system increases vacuum cooling efficiency, but it does not actually cool the produce. Vacuum cooling is a pre-cooling method that is quick, but produce may wilt as the result of the process. Hydrovac cooling is a modification of standard vacuum cooling and incorporates a water delivery system within the vacuum tube. Product is wet at the beginning and then about halfway through the cooling cycle to provide supplemental surface water. The boiling surface water removes the heat from underlying tissues, greatly reducing water loss from the tissues themselves. Hydrovac cooling is therefore more versatile than vacuum cooling, as that it can be used with many more commodities.